Welcome to the deep dive.
Great to be here.
Today we're diving into quite a compelling story. It's about how a semiconductor R&D group managed to successfully upskill its engineering team.
Right, specifically in IC design, integrated circuit design.
Exactly. And for you listening, especially if you like getting smart on new topics quickly, this is a fantastic real-world example.
hmm It shows how a company tackled a pretty big knowledge gap strategically.
Yeah, and the information today comes from Orbit and Skyline Semiconductor Services. They detailed this whole IC design training program they ran for a major R&D client.
In Orbit and Skyline, they're involved in quite a few areas, aren't they? Semiconductor FAB solutions, OEM stuff, VLSI design services.
That's right, VLSI, very large-scale integration, think really, really complex chips.
Right.
But our focus today is specifically on how they help this client train a lot of engineers in IC design.
And the interesting part, they achieved some pretty impressive results without leaning on the usual, very expensive commercial software.
That's the hook, isn't it? So our mission for this deep dive is to figure out exactly how they pulled that off. How did they train engineers who had strong electronics backgrounds, but maybe limited IC design specifics?
And what were the results? The impact. Especially given that software limitation.
Let's get into it. So the client company, who are they dealing with?
Okay, so this was described as a leading international technology company.
Yeah.
A big player.
Right.
And their engineers. Really strong already in electronics, system design, that sort of thing.
So a good foundation.
A very good foundation.
Yeah.
But they spotted a gap, a need to build up specialized IC design expertise internally.
So it wasn't just about fixing a short-term problem?
No, it seems much more strategic. They wanted to own more of their semiconductor projects, really drive that innovation from within.
Okay, ambition, I like it. So you have these capable engineers, but IC design is, well, it's a different beast, isn't it?
It really is. Deeply specialized.
And the first big hurdle sounds like it was access to tools, or rather the lack of access to commercial EDA licenses.
Exactly. ED, electronic design automation tools.
Maybe we should quickly explain those for anyone not designing chips day to day.
Good idea. Think of them as extremely sophisticated software suites. You use them to design the circuits, simulate how they'll behave, verify everything works.
Like super advanced CAD, but for things measured in nanometers.
That's a good analogy, yeah. And not having the standard commercial versions readily available, that's a significant obstacle.
And on top of that, the engineers themselves had limited exposure to the whole IC design workflow.
That was the other challenge. It's not just knowing the software commands, it's understanding the whole process, the design methodologies, the best practices.
The why behind the what.
Precisely.
Yeah.
So whatever training they did, it absolutely had to be practical. It needed to give these engineers skills they could use on actual projects, pretty much right away.
Right. Which brings us to the solution. Faced with no easy access to commercial tools, Orbit and Skyline came up with something pretty innovative.
They really did. Their core strategy pivoted to using open source EDA software.
Open source for IC design.
Yeah. And crucially, pairing that with PDK's process design kits.
Okay, PDKs. Remind us what those are again.
Sure. PDKs are basically collections of files from the manufacturer of the foundry. They contain all the specific rules and parameters for that specific manufacturing process.
Design rules, electrical models for transistors, simulation data, all that stuff.
Exactly. You absolutely need a PDK to design something that can actually be built reliably.
So Orbit and Skyline figured out how to use open source EDA with these essential PDKs.
That seems to be the key technical move, yes. It provided a functional alternative. But it wasn't just, installing free software and hoping for the best.
No, I imagine not.
They called it a comprehensive approach, which involved first identifying and getting these open source tools and PDKs working.
Okay.
Then developing custom training modules. And these were tailored specifically for engineers who already understood electronics.
Building on what they knew. Smart.
Very. They could focus on the IC-specific parts, the methodologies, the things that were new.
And it wasn't just lectures, I assume.
Definitely not. Big focus on hands-on learning, practical exercises, design simulations, letting them test things virtually, and using real-world case studies.
You're making it tangible.
Yeah. Plus, and this sounds vital, ongoing mentorship and support from Orbit and Skyline's own experts.
Oh, absolutely. You'd need that guidance, especially early on in such a complex field.
No question. That continuous support is often underestimated, and they structured the whole thing very methodically, too.
How so?
They used a clear 5-phase execution strategy, started with a needs assessment, really digging into the team's skills, the client's goals.
Makes sense. Know your starting point.
Then curriculum development, designing that targeted training. Phase 3 was implementation and training, the actual delivery.
Yep.
Phase 4, practical applications and evaluations. This is where engineers applied the skills, got feedback.
Testing the learning.
Right. And finally, continuous improvement, looking at results, getting feedback, refining the program. It shows real process maturity.
It sounds very thorough. Let's circle back to the tools for a second, that unexpected angle. Open source EDA.
The key here is that these are free, accessible alternatives.
Which, when combined with the right PDKs,
Allowed them to create designs ready for fabrication, which is, frankly, quite remarkable using non-commercial tools for complex ICs.
it really is. And they also used online platforms, LMS systems.
Yeah, online training and support learning management systems.
Yeah.
Which points to a modern, scalable approach to delivering the training, tracking progress, providing resources.
Okay, so they had the strategy, the structure, the tools. What about the results? Did it work?
The numbers are pretty striking. Over 2 years, they successfully trained more than 800 engineers through this program.
800. Wow, that's a significant number of people upskilled.
It's a huge internal capability build.
And did it lead to actual chips?
That's the other impressive part. The program was directly credited with contributing to the successful tape-out of over 15 IC designs.
Tape out, meaning the final design file sent off for manufacturing.
Exactly, the finish line for the design phase, across 3 different customer projects, apparently.
So this wasn't just a training exercise, it directly impacted project delivery.
Absolutely. Real-world results. So the key achievements really stack up, transforming engineers, even those with no prior IC experience, into capable designers.
And saving money up front on tools.
A significant cost reduction there, yes, which likely enabled the scale of the training. And ultimately, faster project execution, less need to rely on outside contractors for this work.
So looking bigger picture, what were the main long-term wins for the client company, beyond just the individual training?
Well, the strategic advantages look pretty substantial. First, they've obviously enhanced their core engineering expertise. That positions them better for future innovation in semiconductors.
Right, they're more self-sufficient.
Exactly. Second, they now have a sustainable, cost-effective model for training new engineers coming in. It's not a one-off fix.
Future-proofing their talent pipeline.
You could say that, yeah. Which, third, boosts their competitiveness in the semiconductor market. Having that in-house skill is a big plus. And finally, the program itself sounds scalable and adaptable. They can likely tweak it as technology evolves, as new design challenges come up.
It sounds like a really well-rounded strategic success story.
It really does.
So if we wrap this up, the core takeaway from this deep dive seems clear. It's a powerful case study showing how you can upskill a large team in a super specialized field cost-effectively.
Yeah, by being creative with resources like those open source tools and focusing on a really solid hands-on training approach, the results speak for themselves.
It definitely makes you think.
Which leads to a question for you listening in, especially if you're interested in learning quickly or solving complex problems.
Go on.
What other fields, ones that seem maybe intimidatingly complex, might actually be more accessible than we realize? If we just find the right approach, focus on the fundamentals, and cleverly use the tools that are available, maybe even open source ones.
That's a great thought to leave people with. It challenges assumptions about barriers to entry.
Exactly.
And just to mention, if this story piqued your interest, the company behind it, Orbit and Skyline Semiconductor Services, they do offer a range of services in this space, including training.
Worth checking out if this is your area.
Absolutely. It's just a fantastic example of how that strategic learning, that bit of ingenuity, can really bridge knowledge gaps and unlock innovation.
Underscores the value of creative thinking in upskilling, really, in any industry.
Couldn't agree more.